Good morning everybody. Today we are discussing the next topic in inorganic chemistry, representative element 2, that is the reducing property of the hydrogen peroxide. So yesterday we have discussed the oxidizing property of the hydrogen peroxides in both acidic and basic medium. Similarly, the hydrogen peroxide can have the reducing property in both acidic and basic medium. So it is act as an electron donor and we will get the different product in different medium. Let me moving into the acidic medium. So in acidic medium, hydrogen peroxide decomposes to give acid H plus, oxygen and electron. Whereas in the basic medium, it will give water, oxygen and electron. Then let me moving into the some of the examples of the reducing action of the hydrogen peroxide in acidic medium. First is the conversion reduces the permanganate ion to manganese ion. Here we can see that the permanganate, this is a very famous equation which we are using in volumetric analysis, permanganometry volumetric analysis. The KMnO4 is in the presence of acid, sulfuric acid, we will get K2SO4, MnSO4, water and nascent oxygen. This nascent oxygen react with hydrogen peroxide and we will get water and oxygen. So overall reaction is it reduces the permanganate ion MnO4 minus to manganese oxide Mn2 plus. So here in next example, next is the reduction in the presence of reduces the dichromate ion to chromium ion. So this is the equation which is used in permanganometry, K2Cr2O7. Here also we are using the sulfuric acid for the reaction since the K2Cr2O7 is less active than while we comparing KMnO4. So we are using the stronger acid in the case of K2SO4. We are using 4 normal H2SO4 in dichrometry. So we will get K2SO4 plus Cr2SO4 thrice plus water plus oxygen. So hydrogen peroxide react with oxygen and get water and oxygen. So next is the reduction of manganese dioxide to manganese ion. So here MnO2 react with sulfuric acid and we will get MnSO4, water and nascent oxygen. This nascent oxygen react with hydrogen peroxide and to form the water and the oxygen. So the difference is in acidic medium, hydrogen peroxide react with nascent oxygen and we will get water and oxygen, whereas in alkaline medium hydrogen peroxide will give water and oxygen. Now we are moving into the next example, that is hydrogen peroxide reduces hypochlorous acid to chloride. HOCl is the hypochlorous acid which is decomposes to give hydrochloric acid and nascent oxygen. This nascent oxygen react with hydrogen peroxide and we will get water and oxygen. So in every reaction in acidic medium, the second step is common. The hydrogen peroxide react with the nascent oxygen to form water and the oxygen. So here in this reaction, hypochlorous acid converted into chloride. Next reaction is fifth reaction, reduces the hypochlorite and chloride to hypochromite to chloride and hypochlorite to chloride and bromide to bromide. So NaCl give NaCl plus oxygen, nascent oxygen. So second reaction is common, nascent oxygen react with water and to give react with the hydrogen peroxide and we will get water and the oxygen. Next reaction is it reduces the chlorine and bromine to corresponding HCl and HBr. So in this reaction we can see that the chlorine react with water and to give HCl and nascent oxygen, and this nascent oxygen react with the hydrogen peroxide and to give water and oxygen. So hydrogen peroxide can reduce as hypochlorite to chlorine and chlorine to chloride. Similarly, the hydrogen peroxide can reduce as hypobromite to bromine, and it can also reduce as bromine to corresponding HBr. Now, the reducing action in basic medium. In alkaline medium, hydrogen peroxide reduces halogenous to corresponding halide ion. So yesterday we have discussed the conversion of the halide to halogen by using hydrogen peroxide. Here we are reducing the halogen to corresponding ion. So iodine react with KOH plus hydrogen peroxide, that is KOH for providing the basic medium. We will get Ki plus water and oxygen. So next reaction is the basic medium KMnO4 react with the hydrogen peroxide and to form the MnO2 plus O2 plus KOH plus oxygen. So in acidic medium we will get MnSO4 and K2SO4, whereas in the basic medium we will get MnO2 in the case of KMnO4. Whereas in the case of the in the ferricyanide which is converted into ferrocyanide. Yesterday we have discussed the conversion of the ferrocyanide to ferricyanide by using hydrogen peroxide. Here the opposite reaction will occur. The ferrocyanide converted into ferricyanide by using hydrogen peroxide in alkaline medium. So it is converted into Fe2, K3 FeCN6 times converted into K4 FeCN6 times. Next is the reaction of the reduction of the potassium periodate to iodine. Potassium iodide. So KiO4 react with hydrogen peroxide and we will get KiO3 plus H2O and oxygen. Next, last reaction is the addition reaction. Hydrogen peroxide can add the multiple bonded compound and we will get ethylene glycol. Yesterday we have discussed the reaction of the ozone with multiple bond. We will get aldehyde. Sometime it may be ketone. So here in hydrogen peroxide it can add the ethylene and we will get ethylene glycol as the product. Next is some of the uses of the hydrogen peroxide. Hydrogen peroxide is used as an hair bleach action and it is used for bleaching the fiber, cloth, paper pulp, leather, oil, fat, textile and etc. It is acting as a disinfectant and it is also act as an antiseptic, and it is used in the manufacture of the sodium perborate and sodium percarbonate, and it is also used in the synthesis of the hydroquinone and tartaric acid, also used in the manufacture of the propylene oxide and polyurethane, and it is act as a rocket propellant, the composition of the rocket propellant, and it is act as a green chemistry. It is used in environmental and green chemistry because it can be used without causing any pollution to the environment.